Hello there. So picking up where we were in the last video, I've connected all the free edges on this model. So let's take a look at the free edge model. And as you can see, no more free edges anywhere around. This took me about 20 to 30 minutes. So take note that it's not very, very long, but it can get tedious, I understand. In any case, let's run the modal analysis and compare the two. So let's go to model, analysis, and let's just analyze this. So after waiting for a couple of seconds, we get more outputs. Close this. So we can see we're getting an actual response to the natural frequency from the structure. We're not getting any disconnects between elements, which is good. It's obvious we're going to get some kind of stress concentration there depending on the loads. It all looks good to me. So moving forward, there's a couple of things that we're going to be doing. We're going to be applying loads and performing a static analysis on this model since we have it completely fixed from free edges. And then we're going to be comparing the difference between those static analysis and a static analysis when we actually include stringer geometry. So this truss, the flanges over here, and then the stringers that go from the root to the tip right here near the leading edge. So let's start off by doing an analysis on pressure forces on the bottom surface. So in the real world, a wing would experience a low pressure side and then a high pressure side in the bottom. That's what creates that lifting force that makes the plane go upwards. Now, this can be accurately described as a pressure difference. So for that reason, we're just going to justify it and say that using pressure forces on the bottom surfaces is adequate. So let's start with that. I'm going to orient it like this. Let me turn off my node so I can visually see it just a little bit better. And let me go to model and load. So let's do on surface. So let me turn on my skin geometry. And this is pressure loads. Now let's select all of these surfaces here on the bottom. So there are a couple of ways to select these surfaces, but the easiest way is definitely just to hover over them and select them. Check. All right, seems I selected this one by accident, so let me remove it again. And that looks like I've selected all the surfaces here on the bottom. So let's press OK, and let's do a force per area. This is going to be pressure loads on surface, normal to surface, and we're going to notice something right here. Let's do 0.15, right, pounds per square inch, and we press OK. And what we notice is that for most of the surfaces, they do go upwards, but for some of them, they go downwards. So these are boundary surfaces, so it's a bit tricky to get the normals to flip. And if we go here to show entities, we can actually look at the normals of the surfaces. So if I go here and I press previous, right, we'll see that for most of them, or go up for the boundary surfaces, it doesn't really tell you. So it's a little complicated. So what can we do here? We can delete all of the loads and then just skip these. It looks like 3 surfaces, and then put a negative magnitude for these. We could also modify the loads. So let's try that first. Let's edit, load individual, and then let's do it on surfaces. So, okay. Like these 3. Those are the surfaces we want. And let's just change that from a magnitude of 0.15 to a magnitude of negative 0.15. So press OK. So quick and easy fix. And now just as a last check, let me check my coincident nodes. Good. Yeah, and it was good. Let's create an analysis set. So this is going to be, instead of a normal modes and eigenvalue, it's going to be a static analysis. So let's do static analysis. And let's do this one, pressures. We're going to press OK. So one thing that I want you guys to notice is when you have this analysis set open, you can open up the tree a little bit further for the master requesting conditions and then the boundary conditions. And if you open up these boundary conditions, it'll tell you what constraint and what load set you're using. So, well, I didn't name this one, but we should be naming our constraint sets and our load sets. But what's important to note is the load set is this pressure loads set. So when we create another analysis, that's going to be static analysis for nodal loads, it's going to be, we're going to rename it, and then we're also going to select it here and change this from pressure loads to nodal loads. It's going to be present once we make that. So just take note of that. I'm going to close this, and I'm going to analyze it. Okay, so now that we have that analyzed, so we can see just a little bit clearer, and I'm actually going to turn off my surfaces as well. Right. So if we go to View, Select, and we go to Deform and Contour Data, we have to select, the latest case. So let's do Deform for total translation. Let's do a contour of on misses stress. Press OK, and let's deform and contour. Right. So you can see, the stress concentrations on the skin, and you might ask yourself, why is it going from the bottom to the top? And you got to remember, this is, finite element analysis. They do these to check, expected results. So this is an exaggeration. So there's a stress concentration there based off of the modal analysis that we performed. Let's see what the actual deformation is like. So it's this little box over here, and then we go to actual deformation. And, it's a lot more realistic. So if we animate it, we see that little wiggle right there. That seems like it belongs on a plane that you would want to fly. Right, now let's look at the internal structure. Turn off the skin nodes and elements, and let's go to just a deform view. And what's something that you notice here? Well, you have the stress concentration where the constraints are. That makes sense, right? Because the constraints are constraining the entire model. But you can also see the stress distribution along the spars. And you have these areas of stress concentration that are at the top and at the bottom. And in the middle, stress is relatively minimal. So what do you think that tells us about these holes over here? Are the holes affecting the stress distribution of the structure? It seems that they're not affecting it that much. And what's actually happening is they're letting us save weight, but they are not affecting the structural integrity of our structure a significant amount. It's back on. So that will conclude this video. For the next video, we're going to be going over doing a nodal load and then also putting in the stringers and seeing how that changes our results.